All right, so it looks like we have as the whole audience right here, and we'll get started. So I want to thank you all for attending my session at ESA. I know that conferences are their own unique bucket, and digital conferences are kind of their own weird thing. For example, this is my first go-to webinar anything. And yeah, feel free to use the chat to ask questions. If you want to use your mic, feel free to do so, but of course, be courteous. And just to get started, I'm Ryan from Armis. For the better part of 2 years, I've been working as a solutions architect director, and my job is to be that technical voice in the room to make sure that client needs are being met and that we're applying ourselves to our full potential. So with that in mind, back in 2018, the real thing that sold me on Armis was that I was in the process of moving an entire office structure and a data center. And it was 1,000 employees, a data center that held, I think, trillions of dollars worth of information, to be honest with you. And the logistics of it were mind-boggling. So we were all in that green bar. Let me see if I can get something fancy to, never mind, we don't need a spotlight. You can see my cursor. So again, if anything is not clear, if you don't hear me, please let me know. So we were in that green bar of devices we knew. We understood them. They were the laptops that we gave to people. They were the server blades. They were the APs, what have you. And even moving those was kind of this massive undertaking because the network isn't really the network anymore. People work from homes. People would migrate to other offices. People would do things that weren't exactly comprehensible. So if you wanted to start your own hotspot in your office and run your laptop through that, you could. So just keeping track of 1,000 laptops was mind-boggling. And we had a CMDB, and quite frankly, I remember my first day at that job of updating my own CMDB entry. Quite frankly, no one really trusted it. And then you had this yellow bar of devices that are semi-agentable. We could install some software of note of traditional endpoint security on them. So your smartphone, your tablet, your laptop, and those, they were visible, but the understanding of them was vague at best. And then there was the scary red bar in 2018, which was about 1/3 of devices of just things that people liked these things, but we didn't understand them. We had no visibility into them, and they just were. For example, the guy in the office wasn't taking his laptop only, he was taking the printer. The guy in the break room didn't only like to take the smart TV, but he also brought along with him a Google Home. I remember there was a very interesting situation where a guy was actually taking a Peloton bike. Just all these things that were now access points and attack surface of this new network because they didn't stay in this old office. People found ways to take them over. And don't even get me started on things that no one thought about, like Wi-Fi lighting. So this was back in 2018 when Armis had started coming up with this passive security solution to all these weird things that no one had given the light of day to. And back in 2018, this was 1/3. And right now, you see this scary bar where that is the majority. Well, that is now. It's no longer the future. We're setting up in more and more networks where the majority of devices are simply unagentable. They're not standard. They don't respond to traditional endpoint security. And this is not only those weird IoT devices. What we figured out from this past, go ahead.
Can you show your screen? I think we're just, we're not seeing your screen.
Okay, let me try.
Now that's perfect. Okay, perfect.
Thank you. Like I guess said, it's all a little weird in the COVID era, so more than happy to adjust. So like I said, this is 2018, this is 2020. The majority of devices that we're seeing are unagentable, and there's really not much we can do about that from a traditional endpoint security route. So with that in mind, the thing we kind of realized as we went along was that we had created a great solution not only for IoT devices, but for lots of things we had not really originally planned for. For example, manufacturing plants. If you have a PLC or industrial controllers, those don't respond to traditional endpoint security anyway. They are weird. If you try to scan them, they will tip over. If you try to install software on it, well, one, good luck, and two, it's probably not going to work well. Same thing with medicine. If you have, let's say, an MRI machine, If you try to scan an MRI machine while it's connected to a patient, I don't want to be in the middle of that discussion with your boss. And beyond that, we also saw these things that we had simply seen evolve over time. Personally, I like tablets because 5 years ago, we didn't really know what to do with tablets. We went through that phablet phase of having very large phones. We thought they were going to replace laptops, but people decided they didn't like to touch their screens as much as people thought. And now their point of sales, their HMI interfaces for various things, they are, Lord, I've seen teledoc tablets. I've seen people using a tablet as a conference room, WebEx, I guess man in the middle for that, in a more genuine way. So a compromised smart TV. The other thing is we also saw smart TVs and cameras kind of popping up everywhere in this new environment we were constructing. And the thing about them was you really didn't fall under our forte. We were InfoSec and we were doing construction of technical environments, but the security cameras were IP cameras and they fell under their own weird niche and we didn't have visibility into them. So it was just another attack surface we weren't addressing. And from all of this and this weird perimeter we saw, we kind of realized that devices were everywhere. We didn't know where they were. They could be in the cloud, they could be on the network, they could be working from home, and they could be in the coffee shop downstairs. And there's also this building war chest, and we'll go over that later, of things that give information, but they give a very partial picture. If you have a CMDB that people aren't updating very well, it's not exactly valuable. If you're doing rapid 7 scans and those scans aren't going anywhere, how valuable is that? If you have a pile of ServiceNow tickets where you're addressing these issues, well, one, you really don't have any control on this environment because you didn't really know where those came from. The context is bad and we'll go more on later. But there's so many silos of information and so many tools that aren't being utilized to their full potential because of this lack of visibility. And because of that lack of visibility, there's no real good way to manage policy. So I'm just going to go put this up on the screen. There's lots of familiar names, and these are a war chest. Everyone wants a new tool, and a lot of these tools just don't get the full attention they deserve because of this limited information. We have NACS, we have SIMs, we have traditional WLC infrastructure, we have automation, incident response. I can go into more details here, but it's a complicated place, and quite frankly, this graph is scary. So let's go on. What we kind of realized all together, including that war chest, is that traditional endpoint security was kind of broken. Asset inventory was, one, limited on a lot of information requirements bases, i.e., we would need people to manually fill out the CMDB. We would need scanning. We would need people to be honestly managing these every day. And even if someone decided to steal their laptop and quit the job, we really didn't know. We had the CMDB and we trusted the CMDB because it was the best source, but it wasn't very good. It was broken. So we had no visibility and we had no real control over it. And network segmentation building on this asset inventory was even more complicated. Because if you're constructing a network from the ground up, you really do need to know if people are sneaking things into your network. And this is not even to mention things that are simply going on that we don't have good visibility into because no one really tells us. For example, your badge reader, it connects to the internet. Do people know that? And the answer is yes, but is it in the CMDB? No. Do we have good traditional endpoint security for it? No. And then there's vulnerability management and incident response, which I bucket together. And you can't really manage vulnerabilities that you don't have visibility into. You don't know what you have, so you don't know what your vulnerabilities are. And incident response is often without context. You receive your stack of, say, we had these devices, we had these IPs that we thought were suspicious, we had these activities, and they're from a million different sources. And one, it's not always real-time and continuous. You can see it, it might already have been gone, it's done, you mark it as closed and you finish. So is your incident response good if it's not being fed with the greatest visibility you can have? And the answer is not really. So what do we do at Armis to fix this? So the first thing is we start with this asset inventory. And this is everything on your network. We really don't care what the device is, to be honest. So your smart Wi-Fi lighting is the same to us as your computer, which is the same to us as your Alaris PCU unit. That's the same as your MRI machine. That's the same as your coffee machine. They have IPs, they have MAC addresses, and they use protocols that we understand. What Armis does is we take information from your network, and how we do it, I'll go into more later. And we create this asset inventory in real time and continuously and keep it up to date. So there's no more updating CMDB entries manually. And with that information, we give you effective risk management with our cloud-sourced database, or cloud-based crowdsourced mouthful database of devices and activities we've seen before. So we can instantly determine when a device is acting strangely. We can give you real-time vulnerability assessment based on that. And we also populate this risk management with vulnerability databases that we subscribe to. If you're in medical, the FDA, the National Vulnerability Database, etc. And with all of this together, we supercharge your enforcement solutions. So if you have a scanner, it's a very useful tool, but it has a very specific application. You can scan every device at 3 p.m. every day, but it's wasted time in a lot of ways. What you could do instead is scan, say, when they come online for the first time, or scan only things that are not X. So I don't want you to scan smart TVs, only scan laptops, etc. And we do this all, once again, real time, continuously, and most importantly, passively. We don't actually interact with your network. Everything we have is read-only. All the information we receive is completely passive. And we don't interact with the devices in any way that would, well, in no way. So we don't tip them over. We don't bother them. We don't cause any sort of network interference, etc. So what are we getting from these devices? So we can tell the obvious things, like the physical, like its MAC address, its make and model, its version, its reputation from these. We can tell where it is. What is it doing on that behavioral basis? If a laptop is going on 443, we instantly understand that is HTTPS request. If we see its behavior and it's acting strangely, we can respond to it. And a very good question that people often ask at this point is, my devices are unique. My network is absolutely unique. How do you know about it? How do you know what normal is? And that all goes back to that knowledge base. So quite frankly, they're right. Their devices are unique, but so are snowflakes. And the thing about snowflakes is I've seen a lot of them. They're cold, they're wet, they fall in January. And with that in mind, if your device is a Windows laptop, it's probably going to run Windows Updater. If it's using DICOM traffic, it's probably in a medical environment that uses imaging. If it is running Apple OS, it's either a MacBook, a tablet, or what have you. These all give us an instant picture of what this device is, and also what is normal. For example, if you have a Windows device that is running Mac OS or Mac OS Updater, that's weird. We'll know it. We'll give you attention to it. If you have an HMI machine in a hospital that is connecting to Starbucks Wi-Fi, that's kind of suspicious. We will alert you right away. And we do this all based on activity we've seen before instantly. There's no wind up, there's no real learning period. We will eventually learn your environment and everything particular to it. But starting out of the gate, we know more than enough to give you accurate, up-to-date information on how every device should be. And you might be asking now, okay, great. So how do we get value from this today? And it really starts with this Armis appliance. It's a little logo on the map, and it can be a virtual appliance. It can also be a physical appliance. The reality is it's a dumb box. It doesn't really do much. It takes in input from other sources. And what it does is it reduces it to a ratio of 10,000 to 1. So what we really want from that data is metadata. We don't decrypt. We don't do deep packet inspection. And we take that data, we anonymize it, we send it to the cloud, and then we begin to build these device profiles based on that information. The information we take in and we prefer to utilize is that we take in a span from a core distribution switch, ideally where you see as much north-south traffic as possible and a good part of your east-west. And we combine that with your SNMP read-only from that same switch to map ARP tables to MAC addresses. And by doing this, we can instantly understand what your devices are. And with this combined with your span and your WLC read-only, we can not only get a great picture of your environment, but also things that are around your environment. If I decide to run a hotspot off my phone in the cafeteria, we can detect that on the WLC. If you are in the Starbucks that's very close to your WLC, we can detect that. We won't get the in-depth information that we would get from the span or the S&P, but we do detect that radio frequencies. So there we have it. And that was a nutshell. So there's a lot of information we just went over. Do we have any questions? Okay, awesome. So with that in mind, let's go to the demo environment real quick. All right, and you can all see my screen, correct?
Yeah, actually, I could see it, and now I can't.
All right, awesome. Better?
There it is.
Super. So the first thing I like to start with is this activity log. And these are the most basic building blocks that Armis sees. So these are the TCP sessions, the DNS queries, the connections, who's connecting where, what are they doing, etc. And a very real question that people are often too polite to ask is just, why do we care? There's 3,200 activities. It's kind of an Excel sheet, etc. And we don't give you this. This is the back end. This is essentially a curiosity builder. So we go to the dashboard. This is what you receive as an Armis end user. It's a fully customizable dashboard based on the individual user. So for example, if I only want sites that are in the US and New York, we can have that. If we only want corporate devices, we can have that. If we only want alerts, if we only want certain alerts, if we want reports that are generated by certain activities, etc. It's really whatever is useful to you. So with that in mind, let's go poke around the inventory. So these are all the devices that are in this corporate boundary. And we've taken the liberty of dividing them into usable categories. And these are all, again, fully customizable. So if we go down, we can start seeing computers. We can see the types, the models, the brands, the MAC addresses, the IPs, where they are. We can see routers, APs, etc. So let's go poke around with the other categories. So inputs. From the WLC read-only, we can also detect Bluetooth traffic. So we can see your mice, we can see your keyboards. We can detect network equipment. So not only your APs and your Linksys, but we can also detect, say, someone else broadcasting. We can also go to imaging and detect your printers and IP cameras and things like that. And other is kind of this potpourri of devices that are in too small of a category to be worth their own category. So your IoT gateways, your PLCs, your VoIPs, your tablets, your thermostats, all fully adjustable. But I want to just draw attention to, this is a VoIP. We know the model, we know the brand, we know the MAC address, we know the IP, we even know where it is based on the WLC traffic. And this is all gained completely passively. There's a huge depth of clarity here and information that is just simply not available elsewhere. Okay, so questions real quick. Super. If we go to computers, and I like to start with computer because computers, quite frankly, do a lot. We can again see this risk factor, which is bucketed out of 1 to 10. So this is a medium risk level 6 device. It is Marie Lewis's MacBook, and it has 2 alerts. So let's go there. So Marie Lewis's MacBook, it is this MAC address. It is this IP. It's manufacturer Apple, the MacBook Air. It's also giving us a username. And this is completely gained passively through the metadata of its outbound traffic. We can also see where we last saw it, where we first saw it, and where we saw it. So with that in mind, if we go to activities, we can see this at this real building block level, but quite frankly, that's not that useful. So we can see it at a connection-based level. And this is us filtering up from activities. And we can see who it's connecting to and how. So this is connecting to a man-in-the-middle device, a Wi-Fi pineapple. And that's probably its alert, but we'll keep poking around. So we see how it's connecting, where, and what sort of traffic, duration, etc. You can see at a service level, so you can see the individual IPs it's going to and what's associated with them. So for example, this one has an internal routing IP, it has Yahoo, it has Google Drive. You can also see the amount of traffic and sort of packet loss and performance of these connections. We can also see at a traffic-based level if we wanted to see it on protocol basis. So we can see its NTP going for time sync. We can see that it's using HTTPS. We can see its DNS queries. How many over time? We can also see this as more of a heat map over here. And we also filter this up again into application level. So when that HTTPS request goes out, we not only see that it's going on 443, but we also see that it's using Google Chrome and that it is using version 57. So these attributes and this activities all filter into risk factors, vulnerabilities, and alerts. Vulnerabilities are more based around what this device is. For example, this one is running a pretty old version of Chrome, I think around like 90 now. So let's go check vulnerabilities. All right, so Google Chrome vulnerability for PDF integer overflow. So if we open that, it'll take us directly to the National Vulnerability Database and give us a lot of detail on what it is and how we can address that concern. So we go there and we can just close it out. We can also see risk factors that are based more on activity, like it's jailbroken domain, and we can also see these alerts again. So we see that it is connecting to this malicious device, Pineapple, and quite frankly, anomalies and alerts aren't always malicious, but Pineapple, I really don't know what you use it for unless InfoSec is messing around. So let's go to that alert. So in plain English, the alert panel will tell you what has happened and what we recommend to do, also what activities have triggered this alert, and what affected devices there are. So you could quarantine it, you can suppress the alert, you can resolve the alert, and you can silence it. But there's a lot of devices here. So you might be asking, okay, well, great, we know there's some alerts. How do we manage this again if it happens? And how do we keep track of this? So everything in Armis is an attribute. Its activities are attributes, and all of these are searchable. So if we go to the top, we can see, for example, anything you want to really search for, as granular as you need it to be or as simple as you would like it to be. So for example, we want alerts in the last 7 days. So we go there and we can see the Pineapple alert. So we want alert and we want it to be, say, free text Pineapple. So we have all the Pineapple alerts. And we can see what devices are connected to them and when this happened, etc. So we can save this as, say, test man in the middle attack. Okay, and if we go to reports, we will see this test in the middle attack, or man in the middle attack, and we can set a schedule to send that to you every day, every other day, etc. You can download it as an Excel. We can also integrate with other reporting capabilities if you find that more useful. And we can also go back to our dashboard. And that report is now addable as man in the middle attack. And we can choose to chart it whatever way we want. So we can have a pie chart. I'm on a diet, so let's do a bar chart. And we will set that up by device name. Okay. So now whenever there is a new device that is connecting to this Pineapple, it'll create an alert and it will update this graph. Likewise, if these devices go offline or the situation changes, they will also update. Okay, and we went through a lot there. So any questions? Okay. So with that in mind, let's go find some alerts. So once again, these are all customizable by who you are and what is relevant to you. Let's start with a botnet infection because quite frankly, botnets are really indiscriminate about what they pick. So for example, this one is going after this Axis M3005 lab camera. So we can again see its MAC address, its IP, its manufacturer, its model, its category, its IP camera type, where we saw it. You can see its activities. And the thing about IoT devices is they typically do very few things. So when it does something suspicious, it's very suspicious. Okay, so these are all internal and you can see its protocols. Let's just go to the connections real quick. Okay, so it started out at this Acme AP and then switched over to this Linksys. And I assume that means it's trying to spread the infection to a Linksys device. And here we are. So we have this botnet infection attempt detected. And this is a very interesting dilemma because one, we have to isolate this. We have to do it in real time because this can spread to a lot of devices. For example, one of the most interesting things when we install into a new environment is just seeing things that no one really expected to be active and actively spreading a botnet infection. For example, that Peloton bike. The reason we understood what it was and what was happening was just because, hey, this guy connects his cell phone to it. That cell phone is type, I don't know, Roger at iPhone. So we asked Roger, it's like, hey, do you know what this MAC address is? Do you know what this IP address is? It's trying to talk to our APs and our IP cameras. It's like, well, it's a Peloton bike. I have it in my office. And really, since you don't have that visibility, you wouldn't really understand what that is without a solution to tell you exactly what that MAC address is tied to and where you saw it. But anyway, I'm going to start rambling because there's a lot of interesting stuff here. So with that in mind, you have these affected devices, this Linksys router, and you have this lab camera, and you have these managing activities. So every time this pops up, we need to instantly deal with it. So let me just copy this botnet and go to make a policy. Policies are dynamic responses to changes in your environment. So if we go to policies, we can see some inbuilt ones, and we can create a new policy. And let me create my own. So we want every time that there is an activity, and that is an alert, and that is alert free text, say botnet. And that's really as simple as it is. You see a botnet attack, take this action. So the policy-driven action right now is to give it a medium security alert, which is an alert, but you can also enforce from here. So if you have a WLC that allows us to block devices, we can quarantine it that way. If you want a qual scan, if you want us to send tickets to ServiceNow so someone can investigate, we can do it that way as well. Essentially, it's whatever is relevant to you in your environment and whatever you think is the best judgment point. So for this one, let's just block it at the WLC. And we'll call it test botnet. Okay. And now whenever we see a new botnet attack on this network, it will instantly block it on the WLC. Okay. So with that in mind, we've dealt with two really malicious events, but anomalies and alerts aren't always malicious. So let's go find some other stuff. So medium severity, let's go to out of profile traffic volume for device. So we have this North conference room tablet that's connecting on port 80 to this outbound IP, and it's sending a lot of out of profile traffic volume. And this is again that concept of normal. So let's go take a look at it. So what happened, it's sending a lot of data and we recommend investigating it. So let's poke around this device. We again see that it is a Samsung Galaxy tablet that is Android. It is running 5.0 OS. And we can see at a traffic-based level that, okay, it sent about 400 gigs of traffic. And quite frankly, I don't really have a good reason for why that would happen. It's not necessarily malicious. And this reminds me of a circumstance where we had something similar. Essentially, we had a conference room at a client or a boardroom, and we just saw every day at 3 in the morning, it would send about 20, 30 gigs of traffic. And we saw it at 3 a.m. one day, and we're just like, okay, customer, do you have a conference room tablet that happens to reach outbound to a cloud-based backup at 3 in the morning every day? And their honest response was just, what tablet? We don't have tablets in our conference room. So we send an InfoSec guy up there, and he's scanning the room, and he finds in the closet an actual iPad just hooked up, just sending out traffic every day of recorded conversations in the meeting room. Needless to say, they bought. And there's a really interesting dilemma. Just like, how would we have known that before? We just wouldn't. It's opaque. Anyway, so we have this alert. We have this out of profile traffic, and we also have an SQL injection pattern between this and a computer. So let's go to this device, and this is a really more unusual circumstance. So we can just quarantine it. We could also set a policy if we see this in the future, or what have you. Okay. So with that in mind, let's also go to another field. Let's go to medical. Medical stuff often is scary, so I like to talk about it. It's also really interesting because medical devices, so we're in the medical boundary now, are usually very set in their ways. So we're here at the medical inventory, and let's go find something that's, say, medical diagnostic. Okay, so we're going to go to this Achillean 1 CT scanner because I can pronounce it. So let's just open that up. Okay, so again, this is a completely passive medical discovery of this device. It is MAC address this, it is IP this, it is the manufacturer of Canon Medical Systems, Achillean model. It's a type CT, Toshiba OS. And we can again see at that minute level of activities that it is connecting to A, B, and C. We can see it at heat map when it sends CT scans. We can see it at a service space level for its internal routing. You can see it even connecting to the FDA when it takes updates from there. We can see its traffic, and we can see that it's definitely imaging from its DICOM traffic. And we can also see its risk factors based on what this device is. But quite frankly, there's nothing wrong with this device. So let's go find risky devices. So we're in the medical environment, and let's go to high risk environment or devices. So we see these high risk devices, and let's go to this first one, this WNSC01. And it is an Alaris PCU. It's a Becton Dickinson. It's a medical therapeutic. And why is it so risky? Like 10 is really risky as it gets. And we see that it's under an FDA recall, and that's very risky. So if we go to properties, we can see not only what this recall is. If we go to this, we can open up the FDA's directions about it. So Becton Dickinson recalling Alaris infusion sets for the pump model 8100 due to tube collapse that may cause unintended delivery. Okay, so with that in mind, we can also scroll down more and get the MDS2 file for it. So if we wanted to know a lot more about this particular device, we can also see its serial. And this is kind of a big deal. So once again, going to that search bar, you can just essentially look up anything that is risk factors in the last, I don't know, let's say half a year, 180 days, that are free text FDA recall, or just FDA. So we have 14 devices that are under FDA recall right now. We have all these medical therapeutic, acute care, Becton Dickinson, PCU. We have the infusion pumps from Hospira. And this is really important. And we want to keep this up to date. So let's go create a report for it real quick. So FDA recall. Yeah, let's put a test so people know about it. Okay. So again, we can go see that FDA recall and we can get the report from it. We can set a schedule to email it, and we can go to the dashboard and we can add that as a saved report. So FDA recall. And again, we can set it for devices, and let's say, since they're all the same, well, they're all medical devices, but let's do it by site. So we know which ones by site need to be recalled. So we can see by location how many are there, and it'll update again in real time. Okay, so let's go find some alerts. So we have 2 alerts right now, and they are about external internet access. So we see this MindArray medical therapeutic cart, and it's connecting to external internet. So we see that it's going outbound, but it's loading, so we'll go back to the alert. And quite frankly, this is something we always underestimate. It's just the human factor in medical or even industrial or just standard. For example, most MindArray therapeutic carts and essentially anything that uses an HMI is accessible on at least Wi-Fi, at least some internet connectivity. So if you're running late hours at the hospital and you have a medical therapeutic cart that's not connected to anyone, you might decide to, well, I'm connecting it to my phone hotspot so I can go to Facebook on the console, or I'm connecting it to the Starbucks downstairs. So there's a lot of things like that where people are simply being the biggest barrier to their own good security and hygiene. So what do we want to do about this? Okay, so right now, if there's a restricted connection on this device of medical, it sends an alert to us. We can also have it send to a qualia scan. So if this wasn't a medical device, don't scan your medical devices. It would launch a qualia scan. We can have it as service now, and we can launch a next post scan. And there's a ton of things we integrate with. We kind of pride ourselves on being a solution that can integrate with anything you have. So let me actually bring up that. So let me share real quick. Okay. So for example, these are just a few things we integrate with at the moment and we're really proud of. I'm sure there's some really familiar names in there. And we really are an effective supercharger of virtually anything, simply because we're providing that visibility to make sure it's being used to its max potential. For example, Rapid7 is a great vulnerability management tool, but it shouldn't be used in certain circumstances for devices that you'll tip over. So don't scan that MindRay therapeutic cart. You have ServiceNow, which is good ticketing and response. We also have the SIMDB port, and that's a two-way integration. So we not only update your SIMDB, but if, for instance, you have your SIMDB with special labels and you want those imported into Armis, we can do it that way. If you have enforcement solutions that you want us to maximize, we can not only give them great visibility into what devices are on your network, but also what their particular day-to-day instant continuous location or where they're connecting to other devices is. If you have, say, like, I'm going to let you ask questions on this one. What do you have if you have any questions about how we can supercharge your current security solutions? Okay, that's fair. So with that in mind, would we like to poke around anything else, any IoT devices, anything you really want to see? We've got about 8 minutes left.
I'm just curious, could you talk a little bit about the home network some more? My background is healthcare IT. So these devices, we used to write the interfaces for them, which made them insecure 15 years ago, but like the ventilator pumps and all that. But really, one of the things that has crept up on me as long as I've been in this industry is the TV, the toaster, the fridge, just those things like Tiffany was saying, she could scan those things and then, the information that you find, what do you do with that?
And that's really an important part of actually crossing these boundaries between data silos. So, you can scan them. Well, one, you're going to probably break a few of them, use at your own caution. But also that data doesn't always go to somewhere useful. For example, if I want to update that CMDB on every smart TV we see in patients' rooms, well, good luck on that one. It's a lot of manual work. And quite frankly, there's a million things to do every day. And with the HMI, that's always an interesting thing because they typically are seldom updated. So I, for instance, will see HMIs that are running Windows 2003. I've even seen a few that are running 1995. And not only is no one really actively seeing to their security needs, but also they're extremely vulnerable. Not only are they vulnerable, but everyone knows they're vulnerable for the last 15 years. And really how you have to manage that is, again, with passive security solutions and good data hygiene. And with that all together, Armis is a great solution for it. we don't scan. We get information in real time, continuously and passively. And we also can effectively give any other devices in your network we can give them easy access to your SIMDB to keep track of, along with actual enforcement solutions for things that you can scan or you can enforce against. Okay, good question. All right, so we have about 5 more minutes. And yeah, I feel this is as natural a stop as any. If you have any questions, I'll hang around for a few minutes, and thank you all for your time. We have a hard stop at 10:20, and a good speaker is going to be right on as well. So stay tuned, etc.
Thank you so much.
Thank you.